Well, we have two aspects actually. We are part of the damage survey team, both aerial and ground survey, in the event of a major tornado event. The other aspect is we're following primarily the Dow radars to photographically document visually what the tornadoes are doing while the radars are scanning them. Even though we have a wealth of high-resolution data from the Dow radars of the velocity and echo structure, very little documentation of the visual characteristics of the tornado have ever been documented. For example, when you see the funnel, some knowledge of where the maximum winds are in relation to the funnel is important. When you see a tight rotation, is there a visible funnel or is there not? These are some of the issues that we're very interested in. The reason why this is important is although we have tremendous amount of Doppler radar data, high resolution, there actually has not been a lot of good photo documentation of the visual structure of the tornado at the same time. And that's actually very important. When there's a debris cloud, when there's a funnel cloud, we actually don't know this very well compared to the Dow data. It could be that there's a very strong rotational couplet, which is a signature of a tornado, and there isn't even a visual funnel. These are the sort of things that we would like to be able to document very carefully. Well, what we do is we set up right next to either the Dow radars or one of the other radars, and the reason we do that is we actually do something called a photogrammetric analysis of our tornado pictures, which is just nothing more than a fancy term for putting an azimuth and elevation grid, and we superimpose that right on top of the picture. Since we're standing at the radar site though, that means that we actually also have the radar elevation and azimuth angles. They're the same, one and the same. It's very easy then to superimpose the radar data right on top of the picture. We're going to try to be as close to the tornado as possible. I think the Dow's often set up like 10 kilometers or so, maybe even closer to the tornado, and that's what we would like. Of course, we'd like it to be very close. Well, as Ted Fujita used to tell me, the damage surveys are important because that's ground truth. It doesn't matter what the radar says, the tornado hasn't started until you start seeing damage on the ground. So it's the ground truth, very important. And plus, for example, at the lowest elevation angle of the Dow, again, it doesn't matter what the wind speeds the Dows are showing, we want to see what's actually happening at the ground. It may be there's a tremendous difference, which means that the wind speeds at the ground are quite a bit stronger or maybe weaker than what the Dow radars are showing. And so it's incredibly important to do these post-storm surveys.